There's a big myth in the industry that inference is negative margins. Inference is not negative margins. People are, for the most part, generally, like, not selling $1 for 90 cents. But why does that impression exist? Well, one reason is the sort of Codex and Claude Code of the world, where you have a couple of tools that perhaps give people access to substantially more compute for their dollar than they would otherwise get through the API. And then, of course, those got extremely popular, and now the companies offering those kind of deals have to sort of like figure out how to make it actually sustainable in the long run, whether that means shutting down programmatic access, whether that means like using smaller, cheaper models more often. So the question is, if you want to take control over your own cost, is what can you do? Because the frontier models have gotten substantially less expensive on a sort of per unit of intelligence basis. If you look at, the cost of a frontier model a year or 2 years ago and the cost of a frontier model today, they're roughly equivalent in terms of per million token price. Just the one today is much, much smarter. Now, the issue is that because these, frontier labs are so dedicated to building that next very smartest model in the world and then serving it to as many users as possible, there's somewhat less focus on small, cheap models. I mean, there's the minis and the flashes and the haikus of the world for sure, but even those are fundamentally like very capable and very expensive models.
Hey everybody, welcome to CTO Confidential. I am here with Philip Kiely, who is the author of Inference Engineering and an early employee at Baseten. Philip, welcome to the show.
Hey, thanks so much for having me, Mike. Let's do it.
Amazing. Well, we met. I'm wearing the shirt at AI Engineer Miami.
Great
so
conference.
That was a great conference. You gave a great talk on quantization, which I have to admit I did not fully understand until I saw your talk, which was awesome. But taking it back from there, I always like to start these shows off kind of with, what's your origin story? How did you get started? What brought you to getting involved with Baseten and writing and all that you do?
Well, I mean, you've got the superhero comics behind you. You got the Marvel wall. We love origin stories in the comics.
That's right.
I was bitten by a radioactive GPU, and I'm just kidding. I've been in this industry for a while. I joined Baseten in January 2022, which was almost a year before ChatGPT came out, and that's kind of how people in the AI industry like measure our OG-ness, is like pre or post ChatGPT. So I like just slid in there. But there have been people who have been working in this industry for a decade or more before I showed up. And it's been a really interesting journey because you kind of see new technologies sometimes and you're like, oh, that's going to be big one day. And, the internet was a thing like that. Cloud was a thing like that. But the adoption cycles of these, from kind of early adopters to sort of peak hype to ubiquity, was measured in decades. We still have companies who aren't fully on the cloud. I think just about everyone's on. Yeah, I think we have. I think we're more or less like having some good levels of everybody's on the internet. But
everybody's on the internet.
What's been so interesting about the AI industry is the pace of the adoption curve, where we've compressed what was, a couple decade long cycle in the past into a couple of years. And that's, it's been fun. It's been exciting. It's been a little bit difficult to, hold on for the ride. And yeah, I've just had the fortunate privilege of having a front row seat to this industry at Baseten and understanding the evolution of, all of a sudden, we use some ML for some internal workflows and, maybe to do a little bit of decision making, to all of a sudden we have these generative AI models. They're at the core of our product. They're in the critical revenue flows. How do we change the way we think about infrastructure around these models because of their increased size, increased volume, and most importantly, their increased sort of mission critical nature in building products today?
Yeah, it's so interesting because for me, it's interesting you were before because I always said there were always these ML kind of products beforehand. And I had done a few builds at like an ad agency I worked at where we used some off the shelf products. One of them was like, this was a very common use case, which was taking photos of artwork and then being able to pull up info about the artist. And we had to do a bunch of training. And I always kind of use that. But most of my customers, nobody had enough data to make ML really worth it. And then ChatGPT comes along and agents and just AI and like the general purpose giant model that basically is like, hey, we know enough about the world that you can actually use this and you can communicate. The way I think of it is it feels a lot like I'm communicating with my computer the way that like Tony Stark programs in the Iron Man movies. And I think that as much as some people kind of hated that, I hated it the very first time I tried it, and probably the second and the third, but like I just kind of kept forcing it. And then it gradually just grew on me. But it did seem to happen super fast because your initial thoughts with ChatGPT, like you said, it kind of came out and then it felt like everybody suddenly had these models, which is unlike anything else I've ever seen in my life. Because I would have thought, and I guess maybe this was OpenAI's mistake, that they would have had the patent, so to speak, on LLM, and it would not have been something that. But then suddenly there was Claude, and there was Gemini, and Amazon, and you were like, wait, everybody's got this, like out of nowhere. It felt like it was out of nowhere. Everybody had this, and everything was just getting in this arms race.
Yeah, 100%. I mean, that's the world where there's 3 or 4 companies who have the resources, the data, the GPUs, and the engineering talent to train a great model is not a world I want to live in, where the rest of us are just renting our intelligence a token at a time. I don't find that a very compelling vision for the industry. And fortunately that's not how it's played out. Where, there are millions of open source models on Hugging Face now. And it's interesting what you say about having experience working with companies who really want to do ML and not having the data for it. Because the same thing is playing out in the AI space in that, companies are saying like, wait, I'm spending how much money, how many millions of dollars a month on my OpenAI and Anthropic tokens? Like, can't I do something about this? Well, maybe I can go open models, and for a handful of use cases, I'm going to be able to port that over. It's going to work fine. But, these general models are really good, and I want to build something that's maybe even better for me and my product and is a genuine technical differentiator and a moat for my users and saves me a ton of money. And so they're like, well, we
Yeah.
got to fine tune some models. But then the thing is like, oh, I don't have any data. The difference is now, though, that the creation of data for fine tuning and the creation of evaluation, the creation of eval loops and reinforcement learning environments and whatnot, where in the sort of ML days might have been a months or years long project, now is a days or weeks project where teams that have the kind of usage of their product that facilitates or necessitates the training of a specialized model or the fine-tuning of a model also have all of the resources that they need to get themselves in a position within, again, like days to weeks to begin developing owned intelligence. And that's really exciting because that means that we're going to see even less vendor lock-in. We're going to see even less dependence on a handful of closed labs. And we're going to see a world where every single company is building specialized intelligence for themselves and their customers. And that's the vision of the industry that I'm really excited for.
Me too. Me too. I think of the same thing. Just in my company, that was one thing I had said to my co-founder when he's like, "This is amazing," and I said, "Yeah, but it's amazing, but it worries me because we have such a dependence." At the time, it was on Claude, and then Claude did a bunch of weird stuff a few weeks ago, and I went to GPT. But then I said I still have the same dependency on GPT. I could be flipping back to Claude, and I kept thinking we really do almost need our own open source model. If it's open source, that we're building it on the back of something that we as a company can rely on, that becomes a proprietary piece, because it is so necessary. And everybody, I think, is kind of holding their breath. Like, are the costs going to go up on this, or are they going to go down? And it sort of remains to be seen. You kind of hear arguments on both sides. It's going to keep going up, or it's going to go down, or maybe we end up with more open source models and we maybe run them locally to bring some of our costs down. And it seems like it's anybody's guess what's going to happen.
Yeah, I have a few perspectives on the cost picture. I think
Yeah.
that there's a big myth in the industry that inference is negative margins. Inference is not negative margins. People are, for the most part, generally, like, not selling $1 for 90 cents. But why does that impression exist? Well, one reason is the sort of Codex and Claude Code of the world, where you have a couple of tools that perhaps give people access to substantially more compute for their dollar than they would otherwise get through the API. And then, of course, those got extremely popular, and now the companies offering those kind of deals have to sort of like figure out how to make it actually sustainable in the long run, whether that means shutting down programmatic access, whether that means like using smaller, cheaper models more often. So the question is, if you want to take control over your own cost, is what can you do? Because the frontier models have gotten substantially less expensive on a sort of per unit of intelligence basis.
Mm-hmm.
If you look at, the cost of a frontier model a year or 2 years ago and the cost of a frontier model today, they're roughly equivalent in terms of per million token price.
Mm-hmm.
Just the one today is much, much smarter. Now, the issue is that because these, frontier labs are so dedicated to building that next very smartest model in the world and then serving it to as many users as possible, there's somewhat less focus on small, cheap models. I mean, there's the minis and the flashes and the haikus of the world for sure, but even those are fundamentally like very capable and very expensive models.
Right. It's interesting because I have found even I've been using GPT-5.5 in low thinking mode, and
Yeah.
and basically have not moved from there for like the vast majority of my programming day to day.
And even that, like, GLM 5.1 would probably do just about as good a job for most of the things that you're working on and do it like much, much cheaper. And the great thing about that is because you have the weights. Now, I'm not like the biggest believer in local inference. I think that definitely the people who are working on it are awesome, and that everyone should have the option of buying their own hardware. But if you look at the sort of history of how these technologies have played out for, 99.99% of users, they're not going to want to set up and run inference locally. Kind of in the same way that like Linux is a fantastic operating system and most people use Mac
Yeah.
or use Windows. So, when you still with open models, you get the advantage of being able to run cloud inference or, run batch cloud inference with a bunch of other people. And then you kind of see the input and the output cost. I got this many parameters, I got this many GPUs and this much electricity. Like, I know the unit cost of what I'm trying to do here. I know the sort of output cost that is going to need to exist in order to make that a feasible business.
Mm-hmm.
And you also have these models that are really built for efficiency, that use a fraction of the number of parameters of the frontier models and retain the vast majority of the intelligence. And so between all that, like, that's where you get the not only the low cost, but also the sustainable, reliable low cost that you can actually model out and build your financial plan around, instead of just like kind of hoping that the policies and sort of go to market capture budget of a given, frontier lab is going to, kind of tide you over for as long as you need.
And how do you feel about, and this is something I don't know a ton about this specifically, but the idea of the vast majority of what I'm using these for day to day is coding, right? And the idea that, do I need the whole model? Like right now, what I picture, GPT kind of just knows everything about everything, basically. And like, is there a world where we say, hey, actually, there's like a coding only model, vastly cheaper, way more energy efficient to run. And if that's what you're going to be doing, and could it even get down to the, oh, you're writing in Ruby? Like, we don't even need to know about all the programming languages. You need to know like these things. Does that world end up happening? Is that a thing?
That is happening. Yeah. I mean, look at, for example, Coso with Composo 2.5. The
Mm-hmm.
Composo 2.5 is a fantastic coding model that is really, really fast, very inexpensive relative to, say, like an Opus,
Mm-hmm.
and offers, you know, not only like high quality software, but also is sort of trained with an awareness of the environment it's going to be run in. And so orchestrates that environment very well, understands how to behave as an agent. And you see increasing specialty too with, coding companies understanding a specific task, understanding that like you can saturate the intelligence benchmark for just that task on a relatively small model via fine tuning. And once you do that, you're in a place where you can save like millions on that task alone in input spend. So I
Yeah.
think you're absolutely right that the world is getting much more specialized. There's always going to be a place for the, mythos or whatever comes after mythos, just like the biggest, smartest do-it-all model that can come up with novel insights and solve Erdos problems and combine ideas from different domains in unique ways. But for most practical at-scale applications, we're going to see the decomposition of the application into a set of tasks and the creation of task-specific intelligence, because otherwise there's absolutely no way that we're going to take AI from the tiny fraction of people in the world who've adopted it today to something that every single person has access to in a sort of economically feasible way.
I can totally see that, because I think of it like, I could buy a Lamborghini, but I still can't drive it at top speed, like around my house. But there's like a part of you that sort of goes, well, I'm just going to do the max thing because, like I just want the fastest car, the best thing, even though I'm not coming anywhere close to using that. And I think about most of my day to day work. There's just like today is a great example. I did a whole bunch of like AEO optimizations to our website, right? Like just totally did not probably need anywhere near. I probably could have done those optimizations with like a haiku or like the lowest, but I just used 5.5 in low mode, but again, we're kind of like doing certain tasks that are important that people pay us for, that like I have companies that are like, I want you to do that. That's like,
Yeah,
I don't need the top model for this. We just haven't gotten to a point, I think, where we're thinking about that all the time. And
for
we're like, oh,
sure.
I can use my light model
Yeah.
for this.
And for the individual developer, I don't think that you should have to live in a world where you make a conscious decision about which model you have to use for which task. I think that level of control should always be available, and that people should have the ability to specify what model they want when they need to. But it's more on the application developer to think about this. Also, like if we're just talking about tokens for personal usage, even the most token maxing of people are still talking about, thousands to tens of thousands of dollars in usage, and
Mhm.
finding trade-offs there. I don't know, maybe there's probably people out there, consuming $1 million of tokens a month. Maybe they have to think about it. But when I'm talking about being cost conscious around inference and coming up with, task specific models, I'm mostly speaking to application developers and folks who are looking at 7, 8, 9 figure inference budgets and figuring out how they're going to knock a zero off. It's less about like an individual's personal use. I also just kind of let it rip.
Right, right. I'm kind of the same way. I think of sometimes there's almost like an abstraction leak around that. When I remember when we used to have to compact And I always felt like that was such a silly thing for us to have to think about. Like
Yeah.
the harness should figure this out for me. I want to just kind of be in this flow. I wanted to stay in the flow state and not have to think too much about that. And I found that as these things have gotten better, I think I never press compact. I know it's in there. I never think about it at all anymore. I just kind of keep going and going and going. And I'm able to stay in the flow for much longer, which is really cool. And so I wanted to kind of pivot us though to your book on inference engineering. For people who don't know, what is inference engineering versus like AI engineering? But you hear a lot of terms.
Yeah, yeah.
So I'm like, yeah, talk to
So
me about that.
it's a subset of AI. It's a field within it. We've spent the last 15 minutes talking about like one of my most favorite topics, which is cost
Hmm.
and the possibility of using open models and fine-tuned models to reduce cost. Well, if you want to use an open model or a fine-tuned model, how do you actually do that? You have the weights, which are a giant file just like sitting on a hard drive somewhere, and you have a GPU, I guess, maybe, and you take the weights and you put them on the GPU, and then you somehow have to like put input in and get tokens out of that, and then you have to do it fast, and you have to do it at scale, and you have to replicate it horizontally across thousands of GPUs and keep them alive. Like, that is inference engineering. It's everything that goes into taking a model and getting a usable API.
Very cool. So this is cool because the first time I got a new desktop, and my goal was I wanted to run local models. This is, I think, and one of the things that started to happen was I started to like have to learn more. So there's a lot of us that when AI first comes out, if you're kind of an application developer as I was, and you jump into AI, you're like, oh my God, there's so many things that I used to do all the time. Now I don't do all these things. If you go a level below this, and then if you start talking about this idea that some businesses are going to start deploying their own GPUs with specialized models, what I kind of remind people is software engineering exists still. I was like, you have to just go into this other spot. And I feel like inference engineering is the next thing. If you were into hardware, maybe if you were a DevOps person and now GPT kind of does all the things you used to do. Well, that doesn't like eventually I feel like your boss is going to say, okay, now we want to do our own thing and we got a bunch of data and we got to fine tune. Now this is the next level of what software engineering is going to become. And it's equally as vast, and AI doesn't know a ton about it because we're just learning a ton about it right now.
Yeah. Yeah. I mean, I tried my best to get ChatGPT and Claude to help me write the book, and they were pretty useless at it, actually, which was surprising. I had to write the whole thing myself. The thing
Damn.
about inference, I am a big believer in this space. I see a ton of job posting for inference engineers. You have obviously, OpenAI and Anthropic and Gemini. These companies employ teams of hundreds of engineers focused on inference, as well as hundreds of researchers thinking about how to make it faster and more efficient. And the not every company in the world is going to need hundreds of inference engineers, but every company is going to need their own inference strategy. Everyone's going to need people and teams who own the uptime of models, who own the decisions around which models to serve and how they should be served, who own the latency SLAs and the product outcomes related to the serving of models, as well as own the cost of their AI infrastructure. And these teams are going to be made up of inference engineers. There's a lot of other fantastic careers in AI, by the way, besides inference engineer. You can work on context, on memory, on harness, on the business logic, the training, the post training, the data curation. Like there's so much exciting work to do. There's a reason why every single AI startup in San Francisco, if you ask the founders like, what are your top 3 problems, hiring and recruiting is going to be in that top 3 for everybody, because there's so much work to do here and so few people who are really experts at some piece of it. But for me, the place where I've bet my career is inference, and I am a big believer in it. I think that even with the help of AI models, even with the leverage that they give each individual developer, we are going to see on the order of like hundreds of thousands of jobs related to inference within a few years. And I'm really excited about that.
Me too. Me too. This is kind of the big, and I think outside of Silicon Valley, a lot of us don't see that, and obviously like layoffs make the big headlines, but I think people forget that there's all these startups that are trying to build. Now there's kind of two levels too. There's inference in engineering and what you talked about, context, pre-training, post. These are hard jobs. There's also a ton of press around everybody trying to kind of hit the lotto. Like maybe I could vibe code a thing that makes me like $1 million overnight and like I can not work ever again. And there's sort of, I think that you get sucked into these like what are people doing? But if you really, and this goes back to this idea that I think if someone wanted to go to school for this feels like the kind of thing that you actually should like read a couple of books on, and like your book. And what is kind of the degree path that someone takes to get into this if they're looking?
Yeah. It depends on where someone's coming from, the advice that I would give them. I would say that the most important thing to understand about inference is that the vast majority of this space is not new. If you read any database paper from the last 40 years, any distributed systems paper, you're going to be like, oh, okay, yeah, like I can see how this applies in the inference world. If you are a algorithm developer, if you're very deep on low-level code, you're going to be like, oh, yeah, okay, CUDA, sure. If you are someone who works on like high-performance systems, if you're from like a high-frequency trading firm or something, or if you're a researcher and you're used to, solving hard math problems or working on physics all day, it's like, okay, yeah, the performance engineering piece, this makes sense. So it's not necessarily a new idea. It's just a bunch of technologies combined in new ways and with a greater sort of interdependence. I think that's the big thing with inference is it's very important to understand the whole stack because all of these pieces interact with each other and affect each other to a degree that's unusual in other systems. But, if you're a student, if you're thinking about like, how do I study for this career? You learn the fundamentals of computer science, which are essential for everything. And then, get involved in it. It's the same advice that I would have given someone 10 years ago about like how to get into web. It's like, okay, get involved in open source, make yourself some VLM pull requests, like figure out how to run models locally, just get good at making tokens and get an understanding of which pieces of the stack speak to you the most. If you're already a professional software engineer, if you're, say, like a site reliability engineer, fantastic. GPUs fail all the time.
Mm-hmm.
If you are an application engineer, great. There's a million application engineers out there who need inference. Go become an expert in inference and then forward deploy and help them, get their models running right. There's just like the other thing I would say is that like you definitely see the headlines and like, oh, these guys are $1 trillion, these guys are $1 trillion. But like we talked about at the beginning, the timeline of this industry has been much faster than all the previous waves of technology. I guess we didn't talk about mobile. Mobile was another decade-long wave.
Yep.
And
Yep.
so there was time in those waves for people to become experts in these technologies. I don't think that, in the world of mobile, a guy who's been working in the industry for 4 years is like writing books about this industry that are kind of becoming definitive. Because inference is so new and because AI engineering in general is so new, no one has more than a few years of experience. And I see people from outside of the industry join Baseten all the time. Obviously these are incredibly smart and hardworking engineers, but they're coming in and making massive contributions to not only our technology and our customers, but the industry as a whole within months in many cases. So it's still very early. Come on in and, let's make some tokens.
Yeah. That's what it's one of the other things I think that gets people a little nervous. And when I came into this industry, I kind of came in through the web, through UI engineering, but I was not, I didn't take like a ton of math courses. I didn't go to school for computer science. I think a lot of folks that went to boot camps kind of came from liberal arts backgrounds like I did. And sometimes they look at things like inference engineering or even, just anything AI, you think, oh, well, unlike UI development, where I kind of was able to come in and kind of use my perspectives from other places and kind of become like a product engineer, I might not have the foundational knowledge. And what I've found though, and what I kind of encourage people to think about differently, that was very different from when I came in and I was just copy and pasting shit out of Stack Overflow and I was seeing what worked and I was learning with this incredibly slow process of like building projects, copy and pasting things, reading a book, trying to apply it. But then I was, you read the Gang of Four book, for example, you can't absorb that whole thing. It takes years to practice. You now have this tutor that basically can help catch you up on things that you didn't understand at a way faster rate than we ever were able to do before. So when people, I think, what I've had people come to me and say is I feel like I can't learn this stuff, or I'm like far behind, or I have to catch up on too much. And I kind of challenge them to say, have you tried the new learning tools that you have at your disposal that are completely different than what we were than like these crude tools that we came up in the industry with?
Absolutely. You can get more trial and error, you can get visualizations and help faster. And I will say that, look, is someone off the street with no background whatsoever in programming or math or science going to be an instrumental part of training GPT-6? Like, probably not. But the vast majority of people in this industry are not involved in the very difficult pieces of say, like pre-training frontier models. There's a lot of places actually where having a background outside of computing is very useful. I think one of the biggest places is evals and designing reinforcement learning environments where having domain knowledge is essential. The upside of some pieces of product development and software implementation being much more commoditized is that like these skills are no longer a barrier to making an impact in this industry. So if, for example, you have a great understanding of what good and bad outcomes look like in your field and you're able to codify that, then you can make a big contribution to developing sophisticated intelligence for your field. And so I mean, I do have a pretty substantial engineering background. I went to school for computer science. I was like okay at math. I got like a B- in statistics, but like I passed, I definitely am no, PhD researcher by any means, and I've still been able to hold my own in this field. And I think that, people of all backgrounds, if they're willing to, put in the time and, like you said, use newer learning methods and tools, are going to be able to come in and be surprised by how quickly they're able to make an impact here.
That was kind of me too. It's not that I went to school. I didn't go to school for computer science, but I didn't do particularly bad in math, but I wasn't like I wouldn't have considered myself a math person. Like, it wasn't how I saw the world, like in general, even just writing software all these years. I heard this thing once that some people view software as more like literature and others view it more as math. I definitely found myself more in the literature camp, like very into the language mechanics. I like learning different languages. I got very into kind of maybe the syntax and trying to make it more beautiful. And so when AI kind of came along, it actually didn't bother me a ton to be able to describe things. I actually kind of enjoyed that aspect of like, ooh, I can like write this in English and it could come out the way that I wanted to, and I could just kind of make these moves happen. And I think that there's still there's just so much software that needs to be written. That's what I tell people. And so wherever you find yourself in that space, there's still a lot of work to be done, because I still look at, it's a great example. My landscaper, I got the bill right here. He doesn't have any software. It's handwritten, like it's just, I look at like Main Street. I tell people all the time, I'm like, look at Main Street, look at your local pizza shops, look at all these places, a bunch of them now. I see it all the time. They're like on Facebook, they're like, we just implemented like AI ordering and we got rid of Uber Eats. And I'm like, okay, now imagine that every restaurant now who's been dissatisfied with Uber Eats is now sitting here going, I want to deploy this. They've probably deployed a ton of it themselves, but there's like rough edges when
Yeah,
I can tell. I go, oh, I could make that better for them if they wanted that. And so I kind of think of the other side of it too, is if you're maybe looking at this going, all right, that side of things doesn't look great for me. There's a whole nother product side of people that just like didn't even implement software all these years or have been using SaaS products that now have a much better opportunity in front of them.
absolutely. There's the idea that anything that's an email or a spreadsheet could be an application. And now it's, anything that requires a huge back and forth conversation could be an application. There's a lot of rough edges, like you said. Look at just restaurants. Pronunciation of dishes. You have hundreds of different languages coming together to describe the entire tapestry of human cuisine. You have, the specialization sort of regionally. You have customization of dishes. There's a ton to deal with there. And yeah, I personally, my favorite way to order food is just pick up the phone instead of going and clicking, I want this with the button. And you just kind of like describe what you want and then it shows up. That's pretty awesome. And I definitely think that these more flexible input interfaces are going to be extremely popular with customers. And then at the same time, you have the tools and technology now to create extremely standardized outputs from these varied inputs so that the actual production is extremely streamlined once you get the order, into the restaurant, for example. So you're absolutely right. Tons of software left to build.
This is the most fun part for me, is that this world of non-deterministic computing that we've only been in for a short period of time. I just had a project yesterday that I had been thinking about for years, and I kind of finally saw the application for it, which was this like JSON Lisp kind of language where I could like fluidly create UI directly out of an LLM. And so now I'm kind of getting into the application of it. I don't know where it leads, but I kind of agree with just even the idea of just thinking of this for the people watching, like just being able to say to your phone, like, which was easier, going to Uber Eats, finding a restaurant, finding where the pizza was, picking the pizza, adding the toppings, or just saying, I wanted a large pepperoni pizza and putting down your phone. It was easier to just say, I want the large pepperoni pizza, and you pay the guy at the door. So I'm always like, we now are in this place where everybody can have that. And then when you couple that with the fact that Uber Eats and DoorDash, none of them ever became profitable. So people talk about AI being an unsustainable business. I go, that those businesses, I don't think they are notoriously difficult. And sort of the local model of having your own delivery driver or maybe a person for a few restaurants and just ordering direct from the restaurant was still always the best way to do it. We just kind of didn't have a great technology, and it overwhelmed them, I suppose.
Yeah. Yeah,
So
absolutely. Now we can create much more bespoke software at every single layer of the economy. Hopefully that, increases local business. Hopefully that increases the amount of money that stays within communities. And hopefully it's able to, you know, create a world where the same problems aren't solved over and over again, but at the same time do that without concentrating that solution in just a single place.
absolutely. I like to kind of focus on the optimistic upside. And so I know that we've got about 4 minutes left for you here. We've been going almost an hour. And so I always love to end with two big questions. I think one of them you really answered, but I'll give you kind of the opportunity to give it kind of a more polished answer, which is for anyone getting into computer science or just graduating school today, I say, what would you say is kind of the best career advice you would give for someone entering the market right now?
Yeah. I think that there's a lot of talk in networking about, how do you get in touch with people? How do you do cold email, et cetera, et cetera. My biggest advice is that you have to become someone who people want to get in touch with. And the way you do that is by finding, whatever your most unique skill is and going super, super hard on a project that you believe in and making something undeniably awesome. And then everything else will work out. I was fortunate to do that in college, do that again several times at Baseten. And yeah, every time I level up my career, it comes from finding a project that I'm incredibly passionate about and pursuing it like far beyond what would seem rational until I sort of create an outcome that changes things for me.
And really, when you say passionate about I love to specify this. You really were interested in like the subject matter and not so much the trying to build. Was it like trying to build like a business out of it? Because I think there's a big difference that I find people tend to focus on maybe the latter of like, how do I build some kind of a app, like some kind of an app and like an app as opposed to
Yeah.
like really exploring a domain.
Right. Like you have to solve a problem versus index on the solution. That said, when I talk about, do things I'm passionate about, like there is also a reason why I chose to write a book about AI instead of maybe like a book about other things I care about, like jujitsu or the history of Marvel. So you definitely want some business sense in there too.
Little timeliness, right? Yeah, be
Yeah.
timely about it. And then the other one is, aside from, I obviously we're going to plug Inference Engineering, but I always
Yes.
ask people book recommendations. So I know
Oh,
you'll recommend your book, but
I got my
otherwise,
bookshelf right here. Man,
I see you. You must have a lot of recommendations,
are
and it
we
can be
thinking
nonfiction, fiction.
nonfiction, fiction? Okay. Uh well, let's see. I've been reading a lot of strike. Oh, sorry. I'm not talking into my microphone at all.
No, but I see the Stripe Press up
Yeah.
there, which I
Been li-
just love the design of their books, even if
they're
that.
fantastic. And the new Origins of Efficiency book is very interesting to me. I always wonder like why do things take so long? And you know, why don't we just automatically come up with the best solution every time? That's a sort of philosophical question I've always had. So that book was really interesting. On the fiction side of the shelf, I don't know, got to shout out my guy Brandon Sanderson. I as a professional author understand how difficult it is to produce a large volume of work, and he's one of the greatest of all time at consistent excellence. And so if you're into reading, just like pick up one of his series, you'll have a good time. And by the time you're done with one book, the next one's going to be there waiting for you. So I'm trying to be prolific like that.
Amazing. Yeah, I have to say one of my favorite books is called House of Leaves, and I remember reading that book. It's a crazy book. It's like sometimes the text is upside down. It has to be read in the physical medium. Like you
Yeah.
can't buy it as an ebook. You can't read it as an audiobook. Like I've always been impressed by the fact that he used everything at his disposal to make sure it had to be read in this format. And I thought, man, this was what an epic work. This guy probably didn't write anything else. He later wrote, he's got like a freaking 10-volume series of in a very similar style. And I'm like, I'm just blown away that this guy's able to write and be this creative in a way. I'm
That's
envious
awesome.
of it.
As an author, I'm very empathetic with the George R. R. Martins of the world on how hard it is to create to write, and especially how hard it is to write when there are high expectations and you're trying to follow up on success. But yeah, I definitely take inspiration from the most prolific authors out there, and aspire to join their ranks one day.
I think you will. It's definitely, and you have your whole life to do it, which is George R. R. Martin's a testament to that. So
Yep.
it's good. And then finally, where can people find you? Get in touch with you, all that good stuff.
Yeah, so I try and keep my branding pretty consistent. I'm Philip Kiely everywhere. Tokens are sold. Um, I'm on Twitter and LinkedIn as my primary platforms. You can find me and all my work and all my information at philipkiely.com. And I will plug that Inference Engineering, the PDF is entirely free. And then we also have paper copies, which we sell more or less at cost, with shipping to 30 different countries, and a new special edition in India printed and shipped domestically for 825 rupee.
Wow, amazing, amazing. That is awesome. So yeah, I love it. So it's free as a PDF, and then you guys should order it. You definitely should check it out. I think anything you can read about AI up and down the stack is worth it. Even if you don't go into inference engineering, it's worth knowing because the fundamentals are kind of key to being successful. At some point, you can't escape them, is my feeling. So,
Absolutely. Well, thank you for having me on, Mike, and thanks everyone for listening.
absolutely. Have a good one, Philip.